right, one after. We'll go ahead and get started. Welcome to Omnilert's webinar on securing outdoor and large areas, protecting the perimeter. The interest in this topic has been increasing over the last year as we look at vulnerabilities in parking lots, outdoor events, and remote areas. I'm Ara Bagdasarian, the co-founder of Omnilert, and I'll be your guide during this discussion with Eric Polovich and Chad Green from our team. We'd love to learn where you are from, the participants. If you wouldn't mind just posting in the chat who you are, what organization you're with, and if you have questions, hit the Q&A button. There's a chat button and there's also a Q&A button. But if you hit the Q&A button for questions, that would be awesome. We'll take those towards the end of the presentation. But I did share who you are, what organization you're with, and anything that you are hoping to get from the program today. Just to kind of run you through the agenda here, we're going to talk about the reality of modern campuses, what this is all about, look at addressing the problem of how do we effectively monitor large areas. And we've had a lot of experience over the last couple of years in securing large spaces and different types of customers, different types of applications. So we'll share some of those experiences with you. And we'll talk about how it works. Chad's going to take you through how the technology works and really give you a good understanding of the nuts and bolts behind the technology, the magic behind the curtain, if you will. And then we'll take questions towards the end. So before we get started with this, just to give you a little background on Omnilert, for those of you that may not be familiar with Omnilert, I know we've got a lot of customers in here as well. Omnilert's been a trusted leader in life safety solutions for over 20 years with a clear mission to protect people and keep them safe. It's really with a core focus on prevention and being proactive. We've always been sharing that mantra, proactive safety solutions, going back to our emergency notification days. So back in 2004, as a pioneer of emergency notification and multimodal communications technology, helping organizations communicate quickly during incidents. It's all about solving that problem. How do we communicate when there is an incident to keep people out of harm's way? Then in 2019, we applied the same expertise in real-time systems, artificial intelligence, and computer vision to launch Omnilert Gun Detect, a proactive firearm detection solution designed to help organizations identify threats before a shot is fired. And that is a key thing here. We are all about prevention. We've been doing that for 20 years, and that's really been the core of our DNA is prevention, keep people out of harm's way. Today, Omnilert works with thousands of customers and partners across the security industry and all sorts of industries, healthcare, education, manufacturing, government. Our mission is simple: to help organizations detect threats earlier, respond faster, and ultimately prevent harm before it happens. We gotta prevent harm, guys. So to share additional background and to set the stage, I'm going to introduce to you my colleague, Eric Polovich. Eric, it's all you, sir. Oh, and you are muted. That has happened at least once.
Happens every single time. So before we talk about technology, first, thank you, Ara. Secondly, it's important to understand the realities of the environments that we're trying to protect. When we think about a secure environment, it's often pictured as a single building, controlled entry points, hardened exterior, maybe some metal detection or screening technologies. The reality is that most environments that we're trying to protect are much larger and much more open. We're talking about schools, hospitals, corporate campuses, retail complexes, other places where people gather, basically anywhere where people gather. They all have the same challenge. They're large, they're open environments where people move freely between buildings, parking areas, walkways, entrances, and other public spaces throughout the day. That openness of the environment is part of what makes these places welcoming and functional. But from a security standpoint, it also makes them difficult to monitor and protect consistently. And that's really important because these spaces are where violence actually starts. When you think about an active shooter incident, most people start with the moment the shot's fired. But in reality, the incident begins well before that. In most cases, the attacker arrives, might spend time preparing, moves through the environment, looking for that target area before shots are fired. Research from the FBI and other studies show that attackers might be present on premises for 8 to 10 minutes before firing the first shot. And that creates a real critical window and opportunity to detect the threat early and begin response before violence starts. And that's exactly the challenge we're going to explore today. How do you detect and respond to a firearm threat across environments that were never designed to be tightly controlled in the first place? Before we get into it, we can do our first poll question. How does your organization currently monitor outdoor or large open areas for security threats?
Okay, let me get that poll open here. While I'm pulling this up here, I just want to remind folks, as I was typing that in there, to hit the Q&A button if you have questions. So let me see here. Where's the poll? Let's get it out here. All right. Would you mind? Here we go. We got the poll ready to roll here. So Eric, would you mind just set the context again for that, please, as people are responding?
Sure. We're talking about the environments that we're working in today. How do you detect and respond to firearm threats in these locations that, they were never designed from a security standpoint to be tightly controlled. It's important to keep in mind that most organizations already have some sort of coverage in these areas, cameras, patrols, maybe a mix of both. But the reality is most of these systems were designed to observe, record, help you understand what happened after the fact. So what we tend to see at Omnilert is a gap between having visibility and actually having actionable awareness. Did we see the results to that yet?
Yeah, let me do that right now. Let's take a look here.
Security cameras, obviously pretty high, cameras installed, but mostly used for investigations after incidents. That's what we see every day. I talk to professionals in all walks of life, whether it's education, healthcare, corporate interests, logistics, and we know for a fact, 80 million security cameras in the US today, more than 99% of them are used for forensic purposes.
So not surprised then, Eric?
Absolutely not. So let's jump in. Most active shooter incidents unfold really quickly once the first shot's fired. And that means that the moment after the first shot, in many cases, may already be too late in the timeline to act. What we need to do is to focus on the window before violence begins, because as we said, these incidents start well before the first shot's fired. Research into attacker behavior consistently shows that incidents follow a sequence of phases: planning, preparation, approach, then attack. During those early stages, the attacker's usually already on site, moving through the environment in the spaces that he's going to interact with. This is what we call the pre-attack window. The window of time is extremely important because if a threat is detected during this early phase, security teams can begin proactive actions before a first shot's fired. That's really the goal of proactive detection, not just identifying violence immediately once it happens, but identifying violence in the moments before it actually begins. In any emergency, the first 60 seconds after a threat is identified sets the direction for everything that follows. Years ago, we talked about the most important minute, when the response begins, when people are notified, when safety systems activate, when first responders begin moving towards the scene. These actions, if they start quickly, the organization gains the most precious resource they can have in an emergency: time. Time to warn people, time to lock doors, time to start emergency procedures, and time for law enforcement to start responding. Most traditional security methods start this minute late in the timeline. Audible gunshot detection starts response after shots are fired. Seeing something and calling 911 starts the response after someone realizes what's happening. Video surveillance, as we talked about in that poll, usually becomes really useful after the event altogether when investigators review footage. But if you can detect a firearm visibly earlier, you move that entire response window back in time. Instead of starting the most important minute after the first shot, you start it when the weapon appears, before it escalates. And that's really the goal of proactive detection systems like Omnilert Gun Detect, to start the most important minute as early as possible. As we talk about early detection, it's important to understand what traditional visual detection actually looks like in practice. What you're seeing here are examples of gun detection in scenarios where it works really well. The subject's clearly visible. There's enough detail in the image for the system to confidently recognize what it's looking at. This is a high detail view where conditions are usually controlled. The camera has an optimized perspective, lighting's consistent. In these types of environments, visual detection of all sorts performs really well. But as you'll see, even if you're using an advanced multi-step detection algorithm like Omnilert, a lot of it depends on image quality. It depends on the subject being clear enough in the camera's view to show the details required for detection. And that's where things really start to break down when we move into wide open spaces, outdoor areas, because in these large outdoor environments, you don't get that kind of clarity by default. So one thing we can do is to optimize our deployment design for clearer views. So in most situations, studies show attackers arrive on site, they park or move into the area, they retrieve their weapon, they move towards the building, and this is before anything's visibly happened yet. That early presence creates that critical window for early detection and response. If we look at this timeline visually, the path starts in an area like a parking lot, moves along walkways, reaches the building entrance, then continues inside towards the target area. What that means from a security design perspective is this detection coverage should follow movement paths, not just be focused on destinations. That's why covering these large areas is so important. Instead of focusing on only the places where violence might occur, we prioritize these high-value deployment zones, areas people naturally move through, where shooters might arrive, areas along approach to sensitive soft targets, in addition to high-traffic interior spaces. By designing detection around how people actually move through a space, we shift from that reactive posture to proactive security. And most importantly, we push detection earlier in the timeline while there's still time to take action. And Gun Detect is specifically designed to take advantage of those early blink and you miss it moments during the pre-attack window. The AI detects a visible firearm extremely quickly, typically in under a second once the weapon becomes visible to the camera. Every detection is immediately followed by verification, and most of those are handled by Omnilert monitoring centers. Our 2025 average for review and verification was just under 10 seconds. That includes the time to detect, receive the alert, review the image and video, and confirm whether it requires action. Once verified, the alert moves to an escalated status where the system can launch the response workflow that an organization has defined. That's points of contact engaged, alerts sent off to key staff, mass communications issued, device integrations, access control, alarms, all the way up to and including escalation to first responders. This all happens in seconds, not minutes, and hopefully before a shot's fired. So when we talk about the most important minute, this is what it looks like in practice. We get the gun, wherever it is, we immediately take action. But there are challenges, and that's really what we're going to talk about. Before we get into the technical details, let's touch on one specific fact that's really important when deploying gun detection outdoors. As we said, most camera systems were originally installed for surveillance. Their job was to record activity so someone could review the footage after something happened. But detection is a different problem. The goal here is early warning. The system needs to see enough detail to detect. The camera isn't just watching the space, it's actively looking for a specific type of object. So the design question really shifts from how much can the camera see to at what distance can this camera detect a weapon? And that brings us to our second poll question. Ara, if you could bring that up. In your environment, where do you think a firearm threat would most likely first appear? And while we get that up and those questions are coming in, let's sort of set the stage for what we're going to talk about next. We've talked about the challenge. Outdoor environments are large, they're open. Traditional security measures have a hard time because of those very facts. The next question is, how do you actually solve that problem? What does it take from a technical perspective to reliably detect a firearm across these kind of environments? We got some results yet, Ara?
People are still voting here.
Perfect.
Eric, so let me give another couple seconds here and get those votes in. Okay, we'll go ahead. All right, here we go. Let's take a look here. Yeah, I mean parking lots.
Parking lots, not by a wide margin. Yeah, those exterior spaces, obviously, they're sensitive areas. They're areas that need coverage, and in most environments, they're areas that are lacking it. So let's hand things off to Chad to walk through how visual detection works on a technical level, how that factors like image clarity, field of view, and camera placement ultimately determine whether detection is possible or not. Chad?
Yeah, thanks. Well, those are really good results, and it's good to hear from everybody on where the cameras are placed right now. So Eric has already gone over the challenges with traditional surveillance cameras and how they were designed. So I won't spend too much time on it, but we know that it's not a bad thing that you have cameras everywhere and they have a wide field of view and they're just recording. We can use any camera that you've got that can stream to us, but we want to talk today about being a little more intentional about where we place the pixels. So traditional cameras were designed more for observation, recording what happens. So we go back in time, we watch the video, and more of a forensic analysis. But we want to be more proactive. So to get a camera to really be effective at detecting weapons, we need to think about pixel density. So think about it this way. Your camera, if you're right next to the lens, you have the full resolution of the sensor, and it might be a 1080p camera. So you have 1,000,000 pixels. The farther you go away from the lens, though, think of it like an upside down pyramid. Those pixels just spread out. So for the same resolution camera, the same field of view, the farther away you go, the pixel density drops off. And that's what we're seeing in this demonstration at the bottom. So on the left is 100 pixels per foot, where you might be relatively close to the camera. And then as we go to the right, you see what it looks like as the pixel density drops. At the extreme, you can tell that the really important visual features that any neural network would need to distinguish that object from other objects that might be held, those are smudged and smeared and hard to discriminate. So this can be, we can get better at placing our pixels just by modifying either the resolution of the camera or the field of view. What we're seeing now is a diagram that just shows an area below the camera where we have high density pixel per foot pixel density. That's where we're most likely to get a weapons detection. Out farther beyond that area, though, the pixel density drops off and you'll still record information, but not as effective at being certain about a weapon that's detected. So to extend the blue range, we can either increase the resolution or we can decrease the field of view. Either one of those will compress the pixels into an area that's farther away. So high quality detection is dependent both on pixel density and pixel quality, because we also need to make sure that we've got good lighting, that the camera is not obscured, that the lens is clean, and there are tools to help you assess that we're working on as well. Once we have all that, then we have to think about how do we cover a large parking lot or a large area. And I appreciate that most people said their parking lots are not covered. I would guess that that is the case for most organizations. Where do you put the cameras outside? Well, in order to get the high quality detections and good pixel density in lots of locations, the solution would be add more cameras. And that's a good thing. I'm not discouraging that, but I'm going to say later that there's a better way, and we'll introduce that to you in just a few minutes. But if you've got cameras outside already, or you're planning to install cameras on light poles, that's great. Having multiple overlapping coverages is a very good thing. You have redundancy. You can see the weapon from multiple angles. You're just increasing your probability of detecting that weapon. You can see in this diagram, there's some cameras that might be a multi-sensor camera where you've adjusted one of the fields of view to be wide and another of the fields of view to be narrow. And the more narrow it is, the more you're extending the range of being able to detect that weapon. But what about another solution? We have technology partners now that can put the whole solution into a box so that it can be mounted on a light pole out in your parking lot. It would use the power of the light pole at night when the light's on to charge batteries inside the box, and then it'll run all day on the batteries when the light is off. There's also solar panel solutions too that can be attached to this. But another really interesting part of this is introducing a new camera technology where we can actually extend the range of detecting weapons, not by changing the multi-sensor camera lenses themselves, but by adding an automatically triggered PTZ camera. So this is a camera that has 4 multi-sensors in a ring. And then we can configure each of those multi-sensors to trigger on motion rather than needing to wait for somebody to get close enough to detect a person or a weapon. When it triggers on the motion, then it automatically slews the PTZ to that location and zooms in, so we get the pixel density that we need. So instead of this fixed high pixel density area, we can extend out beyond what the traditional camera would have detected. So here's some demonstrations. Here's one of those very cameras out in a parking lot, and it's detecting this test event where the person is walking in the parking lot. It detects that person and their motion, and the PTZ camera starts to zoom in, and we get the gun detection. And then after the gun detection, here's what's really important. We get tracking on that person, so they continue to move. I'm sorry, Eric, can you go back and let that play through, that second portion of the video? Just want to show that this person is automatically being tracked as he moves throughout the parking lot. And we stay at a zoom level for high quality detection. We're not showing the detections in this video. This is just to show the tracking. Okay, go to the next slide for me, Eric. Let's watch the next video. So here, the camera detected motion over in the top right corner of that person in the orange vest. And as they become more visible, it zooms in on that person, and then we get to see what they're holding. And there's the handgun right there. And go ahead and let that play through, Eric. And we'll continue tracking that person through the parking lot. So this is an enabling technology. Go ahead and move us to the next slide if you don't mind. Great. So the way this camera works is it uses those 4 cameras to set up multiple detection zones within the field of view of each of those cameras. I think you can set up to 4 motion detection zones. So you can create areas within the field of view where you don't want people to be, and you can trigger immediately on motion. And that range is outside of the range of weapons detection. But since the PTZ can slew to that area automatically, we can detect those weapons outside the normal range of the multi-sensor cameras. So this allows us to go from maybe if these were 5 megapixel cameras and we were getting 80 feet of range before for weapons detection, now we can get 100 to 200 feet of detection with the PTZ. The PTZ itself, actually, if you zoom it all the way in, we can detect things 300 or 400 feet away, but we have to detect motion first. So motion only needs maybe 10 what would be 10 pixels per foot to detect that motion, rather than needing something to get close enough for 30 to 40 pixels per foot for weapons detection. All right, so let me break down the solution a little bit more. What we have inside the box is an Omnilert Edge appliance. This is a small, low-power, ruggedized appliance that's able to process all 5 of the cameras in that assembly. So all 4 of the multi-sensor cameras in the ring, plus the PTZ, and we can process those in real time. So they're 8 megapixel cameras plus the PTZ, and we're scanning those simultaneously in real time. So we can detect people who are close with the standard multi-sensor cameras, and we can detect people far away. What this enables, when you add 5G to this solution, is you can place this system in remote temporary deployments like special events, festivals, and parking lots where you don't have connectivity. Or we can also enable off-network deployments. So now, if you have a secure network that you don't want to introduce a new device onto, this can be completely isolated and self-contained. Also in areas where you just don't have Ethernet or Wi-Fi capability. So we're completely off-grid. And I will turn it back over to Eric and Ara to finish this off.
Perfect. And that'll bring us to our last poll question. This is a simple one. Ara, if you could bring that up. How confident are you that your current systems would detect a visible firearm outside your building before someone enters? And this is really everything we talked about today. It's what it comes down to. This question highlights the difference between surveillance and detection and why designing for detection requires a different approach. We find that most people are very confident in their camera coverage up until they start thinking about using them to detect in real time. It's not whether you have cameras, it's whether those cameras can actually detect a threat before it reaches your building. And that's not to say that camera footprints that are out there today can't do this. It's just that in those specifically wide open environments, oftentimes there's either no coverage or the coverage is lacking. And that's different than, when you're thinking about the detection use case. Yeah, just about what we thought. Those wide open spaces are, well, they're wide open. They're wide open for threats, but they're also a wide open opportunity. So let me, kind of wrap everything up. Large outdoor environments, as we discussed, they're inherently challenging, but they're the world that we live in. Wide fields of view, variable lighting, long distances, inconsistent camera quality. This all reduces detection performance. This is compounded by the fact that traditional surveillance wasn't built for detection. They were designed for forensic review. This creates those blind spots that we're talking about. Threats are visible on those cameras minutes before first shot in many cases. That creates that critical window for intervention. We take the appropriate steps. We transform those systems into active sensors, designed for detection, optimized for pixel density, like Chad mentioned. Look for clarity, usable data, not just wide views. Increase the probability of visibility by using multiple angles, overlapping views. Prioritize those areas where threats emerge first, paths that they're going to move upon, not just the destination. And detection depends on detail. So be sure that you're optimizing your cameras for the detection use case to get the most out of your system. With the right strategy, visual gun detection really does help you start that response earlier. And that is what Omnilert does. We bring all of that together into a solution that works in the real world. We combine advanced AI, flexible deployment models, so detection isn't limited by infrastructure or by environment. That means we can deploy on the edge and remote or restricted networks. We can extend that detection into areas where it traditionally hasn't been possible. We can also intelligently extend coverage using multi-sensor systems, directed PTZs, to maintain the level of detail required for detection, even across these large outdoor spaces. And once a threat's detected, the system immediately triggers the response, alerts, integration, and coordination between your organization and first responders within seconds. It's not just about detection. It's about delivering reliable detection wherever it's needed and turning that detection into action as quickly as possible. So with that, that wraps up the presentation portion. So hopefully we've shown that it's not just about how gun detection works, but how it can be designed and deployed effectively in large real-world environments. And I'll hand it back to Ara for Q&A.
Awesome. Thank you, Eric and Chad. And we've got quite a few questions that came in, so thank you for that. And one I'll answer verbally. Sarah asked if this will be available as a recording. Yes, Sarah. Within a week, we'll have this available for your viewing pleasure to watch it again. So let's take some questions here. First question is human verification required due to regulatory requirements, or is it triggered by false positives? So do you want to talk about the human verification, Eric?
Sure. So human verification can take a lot of different forms. Now, Omnilert offers multiple models of human verification. We obviously offer our own human verification through Omnilert monitoring, and about 90% of our customers go with that. That is for a number of reasons. First and foremost, it's because it enables advanced workflows. It's not just plugging the AI directly into your siren or your notification. This puts a human in the loop, a human that's outside of the stress of the organization on site, someone who's professionally trained to verify and take action and work with your staff and first responders to make sure that response is quick. I see human verification through Omnilert used in higher education, K through 12, and businesses quite a lot. It's not just for regulatory purposes. It's because of a number of reasons. But first and foremost, your security staff already has a lot going on. Watching the screens is what we're trying to get them not to do. We're trying to surface those incidents that they need to pay attention to. However, we do offer multiple models of verification. We have APIs that enable us to plug into other verification partners. So if you have a verification agency that's already monitoring your alarms, your doors, your access control, what have you. We can push the alerts direct to them, let them do what we do, coordinate that review and response. We also can put it out to VMS and other control room platforms. So if you've got people staring at screens already, looking to source issues, whether that's brought up by motion detection or some other analytic, you can add gun detection to the mix. And we do also push directly to cell phones, desktops, via our app or other options. We do have, I saw someone mention in the chat, an open API. We do have an open API that allows us to push from the gun detect system out or in to trigger gun detect events. Did that answer the question sufficiently, Ara?
It certainly did. We certainly did. We got a question for Chad here. What is the average range, depending on camera quality and conditions, of course, that cameras detect and start tracking? You touched upon that briefly, but if you wouldn't mind just going a little greater depth on that, Chad.
Is this specific to the multi-sensor camera? I assume so, because we talked about tracking.
Yeah.
So it's motion detection. So the cameras, I would say they can detect motion out to 100, 150 feet with the cameras that they have on the multi-sensor ring. And then from there, the PTZ just zooms in and we can grab all of the detail that we need.
Oh, got it. Thank you, Chad. And then another question similar to that is, how is the camera choosing where to zoom when there are multiple people in the same area?
That's a good question. It has a little bit, the built into the camera is a little bit of smarts to avoid having it just flip back and forth. But it just tries to, you can configure that, how long you want it to dwell on a certain target and then switch to the next. That's a setting within the camera.
Got it. Thank you, Chad. Eric, this one is directed towards you. Someone asked, what happens after a gun is detected? What is typically the protocol from a technology perspective and from a policy perspective?
Sure. So again, I'll caveat this at the front. We have multiple workflow options depending on how your organization would like to handle these events. We default to a standard workflow, which is end-to-end detection, verification, notification, and escalation. So I'll stick with that. When the gun is detected by the on-prem API, the first thing it's going to do is it's going to send it out for verification. And that can be, most of the time, Omnilert monitoring, can also go directly to your security operations center, your staff, what have you. The Omnilert monitoring agent reviews a video and a still, verifies that this is an object of interest that needs action on-prem, and they move it to an escalated status, or they move it to a confirmed status, depending. That confirmed status is going to trigger, well, first off, it could trigger a number of integrations, but it's also going to trigger communications with on-prem staff via a push notification. Here's the data, the image, the video, the location, any metadata associated with it, and perhaps an old school phone call to the primary point of contact to engage in case we need to escalate. Now, from either of those venues, staff has the ability to confirm that verification and move it to an escalated status. When it moves to an escalated status, we can take additional steps. Reach out to law enforcement, local, directly via public safety answering point integration. Engage them and share that data, those images, those videos, that location, that metadata. Coordinate communications between on-prem individuals and the dispatcher. So we have that end-to-end communication from the arriving officers to the organization stakeholders. Trigger integrations so that we can, again, lock doors, trigger emergency notification, etc. So you're not just getting verification. It's not just saying, here's a gun. We're taking it from detection all the way through to action. And if you're using Omnilert monitoring, that individual will be there to facilitate as additional detections come through.
Eric, you said something very important, and I want to emphasize that, is interoperability, making sure that all of your technologies work together, whether it's Omnilert or any technology. You want to make sure that those technologies, all of your technology, your security infrastructure works together, because the idea is once a threat is detected, you want to detect a threat as early as humanly possible, and even beyond human. Obviously, that's the whole point of the AI technology, is to exponentially enhance the ability of a human to detect threats. but then automate response and having all the technologies, your access control systems, your camera systems, communication systems, et cetera, all work together. Ted asked a question that kind of ties in with that. So either one of you can take this. Ted asks, how does your product interface with existing surveillance infrastructure? Want to take that, Eric?
I can jump on that. Sure. So in a number of ways. First off, when we're looking to monitor existing cameras, as long as it's an IP camera that can give us an RTSP stream, we should be able to utilize it in some way or another. As Chad mentioned, clarity of the image and pixel density is important to determine how far from the lens we can detect. We tend to default to 1080p cameras because that's a sweet spot. That gives you detection out to about 30 or 40 feet from the lens. That's good in most interior spaces, entryways, loading docks, etc. We could also detect on a 720p camera. It's just going to shorten that detection distance. Not great for an outdoor space. Might be perfect for entryway, a vestibule, posted right in front of the front door to get people as they move through. Higher resolution cameras or the motion directed PTZ that we showed today push that detection distance out. When we're talking about the rest of, you said camera infrastructure, so I'm assuming it's not just cameras. When we're talking about the rest of your system, your VMS, what your VMS is integrated with, your other on-prem infrastructure, we can integrate in a number of different ways. We do have direct integration from the on-prem server to most video management solutions out there and to many other security technologies. So we can push that detection to the VMS, trigger its event and bookmarking capabilities so it can do what it does best. Start recording, bring up the active camera, flag it as a gun detected event, push integrations based on that. If you're familiar with, somebody asked about Genetec. Yes, we are integrate with Genetec, Milestone, Avigilon, the list goes on and on. And what we do is we allow you to use their event handling procedures that are very deep. So it could selectively trigger alerts, bring those up for whoever's sitting in front of the console, etc.
Eric, we're geeking out on the technology a couple days ago, and you mentioned like a use case where a gun is detected in a parking lot. Part of that initial action, once it's verified, is to automatically lock the doors. Mm-hmm. If it's identified as not a threat, then you can cancel that, and then it unlocks the doors. So you go from lock to lock.
And we're deployed in a few sensitive locations doing that today. There's a number of different decision points along the path from detected to escalated where you can trigger integrations. And those could be, as you said, trigger one to lock a door, trigger another to unlock it, trigger one to move it up a status, trigger another to move it down, depending on what we're integrating with.
One of the key things is the importance that we talked about human in the loop and the importance of context in human in the loop. For example, you may have a corporate party in the parking lot, and someone has a realistic looking squirt gun that looks like a firearm. If that was detected, and it will get detected, we detected over several thousand guns last year, actual guns. If that is detected, sending that to someone who has context of the actual situation can determine, no, that's Eric Polovich in the parking lot with a squirt gun. We're having a squirt gun war this afternoon. Cancel that request. So don't process it. So that's just the importance of human in the loop.
Yeah. And passing on that context is a big part of it. It's not just an alert that pops up and says, there's a gun on camera A. You're getting that information with it, when it goes through verification. It's a firearm, yes, but that's a uniform. That could be a uniformed officer. There's an orange tip on that gun. We think this is something that doesn't need to be addressed. However, I mean, if I think about so many K through 12 institutions that we work with, when there is a realistic weapon on premises that's an edge case, they want to know about it. Even if the worst case scenario there is this is a weapon that we've determined that we don't need to address. But many locations are zero tolerance. If you brought on an airsoft gun, or if you brought on a realistic squirt gun, or if you brought on something that we were actually just getting detections off Star Wars Day events where we had people in costume with replica weapons. That's something that security teams want to know about. Because what if there is an escalation to first responders? Having that context to arm them with is just as important as having the context of this is a real weapon. I'm walking into a situation where we believe this is a replica, and you should know this as you walk into the door.
This is not a real lightsaber, right, Eric? All right. So we have a technical question here, and we should next time we will ask our participants also what their background is, if they're technology based, operational based, safety. So here's a question: Are you taking taking a second stream of cameras and running them through your cloud platform? Any port forwarding needed? Where's the hosting? But do you want to take that, Chad? Are we taking a second stream running through the cloud platform?
Sure. Yeah, we do usually take a second stream because that allows you to keep your primary stream for recording purposes, and then we can have an optimized second stream for detection purposes. But we don't process in the cloud. Everything's processed on premises. We only go to the cloud when there's an alert. So there's no port forwarding that's needed. Just whitelisting certain URLs so that we can get detections up where they need to go.
Got it. Eric, you can take this one. How long has your system been deployed in the market?
Sure. I believe our first deployment our first live deployments, production were 2019. The software was being worked on for quite a long time before that by Chad and his team. But we've been live and in the real world since 2019. So that's going on 7 years now, that we've been working in real spaces. And that's everything from, 2 or 3 cameras at a housing complex in a highly sensitive area, to 8,000-9,000 cameras over an entire citywide installation and everything in between.
And that's an important point. I mean, obviously several years ago it was still considered a new emerging technology, but it's been commercially deployed in thousands of deployments today, operating in very large environments, large school districts, manufacturing centers, hospital centers. I mean, really across the board. So we're certainly beyond that emerging technology perspective. It's still, definitely we're getting there. So let's got a lot of questions here. A lot of questions about the cost. Do you want to just talk, Eric, about is it like per camera, per site? How is the pricing? And obviously we're not going to
So our pricing is licensed per lens. So the annual subscription would really have your first bill would have 3 line items on it. 1 would be your licensing, 2 would be the hardware, and 3 would be any setup fees. But your renewal license would include simply the license fee. And if you go with a subscription model for the hardware, and that would be for the actual servers or devices, I should say, that run the Omnilert AI. There's a couple different configurations that we can use depending on how your deployment is set up, whether it's one location, how many cameras, how many different or how wide apart, how many networks we're talking about. But that means that it's a predictable number year over year. And with that subscription option, it means that we can keep your initial costs down and you have a predictable renewable cost every year.
Thank you, Eric. We've got a few questions here of current Omnilert customers. I think Ricky's got a question here. If I currently have Omnilert, does the camera package have an annual fee? And can you add this to your current VMS? I'll kind of touch upon this. So first of all, I would recommend if you are an Omnilert customer today, you have the whole back end ready to go. And adding gun detect is truly seamless. It's a matter of adding appliances to your existing video network. And we do integrate with almost every video management system, every VMS that lists there. And and that's part of our whole core philosophy, like I mentioned earlier and Eric mentioned as well, is interoperability. It is critical to have open systems that can work together because then it's force multiplier when you have the ability to lock doors, notify people, take over screens, notify law enforcement, etc. Those are all critical aspects. But Eric, any guidance that you would have for current Omnilert customers and quite frankly, why you would not even consider upgrading to that point?
It all comes down to the use cases, I would say. If you're currently using Omnilert Gun Detect and you have a sensitive area that you want to cover, putting a solution like the motion directed PTZ, I should say, is great in specific situations. It's not the sort of thing you'd want in every location. If you've got a courtyard that's a little large, might be a little large for covering it with a 1080p camera, it might be more cost effective and better from a detection use case to put out a number of smaller resolution cameras. But those large outdoor areas where you've got many people moving through them, that motion-directed PTZ works extremely well. We're talking large parking lots like you'd see at malls or locations where you've got thousands of employees moving in and out on shift change, or locations like stadiums and event centers. Ara and I were talking about Bills games the other day and how we would cover a parking lot like that theoretically. The motion directed PTZ would be great for a situation like that when you're looking at a stadium. We're already deployed at a lot of stadiums where we've got tens of thousands of people moving in front of a camera on a daily basis. But having these shuttering cameras, that's not the word, Chad, you were using it before, the movable PTZ that can be directed towards motion, because of the nature of our algorithm and the fact that it takes less than a second for us to detect, that means that the system can actually get a detection while it's on the move in many cases. So having that one high resolution camera sweeping at a far distance means that you're covering the entire arc. You're not just zooming in and stopping and pausing to see what's happened. Once it's passed over that location and we've gotten that 3, 5, or a few frames, we've already had that opportunity to detect.
And so, Eric, just to piggyback, so another question. So this customer has our emergency notification system, and what's involved for them to upgrade to the gun detection technology?
Quite honestly, it would just be a matter of reaching out and speaking with your account executive. They would have all of the information that you need. The emergency notification system that Omnilert pioneered in 2004 is the backbone of how Omnilert's Gun Detect's communication tools work. We leverage the back end to make all of those lightning fast connections, whether it's to local devices or devices out in the cloud, to other devices on the internet. The speed of the internet is really how fast we communicate. Having the Omnilert ENS does enable some integrations that are unique. You have your existing Omnilert scenarios, your existing subscribers, your existing groups. You can leverage those for gun detect alerts, or when you escalate, we can escalate directly to your Omnilert ENS. Now, we also integrate with other emergency notification products out there, so we can get the word out through those tools as well. But the Omnilert ENS integration, just a little bit tighter and a little bit easier to launch with one click.
Awesome. Thank you, Eric. Thank you. This is for Chad. How do you handle low light, dark situations in parking lots or external factors?
I love that question. And it's important to think about. Most of these cameras, most modern cameras, do a pretty good job in low light detection. And this is not a limitation of our gun detect product. It's more a limitation of the camera. If you as a human can look at the image and say, I can definitively say that's a weapon and not a cell phone, the network will be able to do the same thing. So the camera that I talked about is great in low light, very high sensitivity on that camera. I can't tell you the minimum lux that it would take to get a detection on it, but that is a common question and challenge. And I would say just make sure that your camera is tuned to night vision, the night vision profile. Some of them switch automatically. Some you have to go in and mess with your settings a little bit. But again, if a human could look at the image and say there's a weapon present, then the gun detect software will as well.
So this is a great question, and because it also often is conflated when you talk about gun detection. Because you've got visual gun detection, you have concealed weapons detection, you've got gunshot detection. Somebody asked, how is this similar to technology like Evolve? How is Omnilert compared to a technology like Evolve, for example, or concealed weapons detection? Eric, want to take that?
Sure. So they're definitely different beasts. They all have their place. Audible detection, monitoring for audible gunshots so that you can act immediately. Evolve and other walkthrough detection systems, even if it's traditional metal detection, they're hardening tools. You're placing them at choke points, at entryways, and you're looking for concealed weapons. They have the ability to, when someone walks through, alert on a weapon, whether it's in a backpack, under a jacket, in a holster. Visual gun detection, a little bit different. We're using that camera footprint, what you already have or a new one that you're putting out there, to give you, well, a second set of eyes, something that cameras were originally thought to be able to do, have people looking at them to see what's happening, but AI is making that a reality. One person's not going to monitor the 100, 200, 2,000 cameras that you've got at your location. It's just not going to happen. And most security teams know that you can only scale up so far, and there's only so many people you can put in a room staring at cameras all day before they go crazy. AI can do it simultaneously, whether it's 10 cameras or 10,000. It has the ability to watch every single one of them with the same attention span, the same detail, and the same repetitive capability 24/7, 365. That's the big difference. We're not a walkthrough detection method. We're not a concealed detection method. We are looking for a weapon appearing in your environment, a gun, so that when it does appear, someone's told about it immediately. It's giving you, it's basically expanding your awareness from what's right in front of you to your entire footprint.
Exactly. And you have the cameras. Chad, did you want to jump in?
Just wanted to add that we're processing those cameras at the full frame rate. So if the camera is giving us 30 frames per second, we're processing every one of those frames. Some other competitors might dumb that down a little bit to process 1 or 2 per second because they need to send it to the cloud. But since we're processing on-prem, we're getting everything. And that allows us to get people running through the camera field of view and very short, brief views of the camera of the weapon in the field of view. We just definitely don't want to miss a real weapon on premises.
Exactly. And to tie those both together, one of the concepts that we're employing here is a layered approach. And really the first layer is the human element, the behavioral side of things. Is there other behavioral issues with an individual that are exhibiting potential elements of concern? Obviously, you want to intervene, but when that fails, from a security perspective, how quickly can you detect a threat as far away as the location as possible? And so with visual gun, and you mentioned this, Eric, so we're deployed in many stadiums around the country, major events. And we've got cameras in parking lots looking for the first site a firearm is presented before somebody even walks up to the front entrance and passes through a metal detector or some other concealed weapons detection technology. So that's a second layer from that perspective. And then the third layer obviously is gunshot detection, but it's after a shot has been fired. And we want to avoid that. We don't want to get to that point. That's the objective here. Let's get ahead of that. Let's not have to even get close to that. So we only have a couple minutes left. Let's take maybe 1 or 2 more questions. I was talking to somebody about this yesterday, actually, about the National Park Service. So what about in a park environment? What if, someplace that is not, that's completely remote? How would you address that? Chad, do you want to take that?
Well, it depends on whether we can get at least 4G connectivity out to that point. We need some internet access in order for the data to get to you. So as long as that's available, it's fine for that pole mounted approach. And that box that we showed can be mounted on a wall or any other piece of infrastructure. And I mentioned we can use solar panels to get the power, or whatever. There's multiple ways to handle that.
Got it. Chad, this is right up your alley as well. How often are AI models updated, and how are those maintained on location? How do we update that?
So every single weapon that's detected, whether it's a true positive or if we detect it on something that turned out not to be a true handgun, we get a small and you get a small video clip of that event. And we take that video clip and we add that to our training database, and we retrain to make sure that next time we're either reinforcing that true positive or we're training out something that turned out not to be a true weapon. And we try to push out new network updates every 2 months. Cadence changes depending on what's going on and what sort of other system updates are happening. But those updates come to you automatically. They get pushed to your device so that you don't have to worry about it.
Another techie question here. Oh, it's not techie, but Eric or Chad, you want to take this? Is Omnilert pushing metadata from the detection to whatever, I guess, to a VMS? Are we pushing out metadata with the detection?
Yeah. Well, when there's a detection, yeah, we use a hook to send to the VMS so that the VMS gets that notification and can bring up the video stream on the VMS. Is that what you meant? We're
Yeah.
not pushing like the bounding boxes. We're not pushing those to the cloud anywhere. Just the alert metadata.
This comes up all the time, Eric. I mean, how do you handle this when somebody asks, how accurate is our AI gun detection technology? We love this
So
question.
this is a long question. We don't have a lot of time left, so I'm going to try and boil it down to just a few salient points. I get asked a lot about how accurate are you, and what's your how many false positives do we see? I'm probably going to turn this over to Chad to get a slightly more technical. But when it comes to accuracy, it's two different pieces. How often do you get the gun, and how often do you get something that's not the gun? False positives are what an AI generates. What we do is we source objects of interest. If it looks like a gun at a glance to a person, that AI is quite possibly going to alert upon it. So when it says, how often do we get the gun? I believe our most recent number is better than 99.8% of the time. Chad can correct me if I'm wrong, but suffice to say, when a gun appears and we see it in camera at the proper pixel resolution, pixel density, we get the weapon. So missing a firearm, if it's visible to the camera, is not something that I worry about. When we talk about spurious detections that aren't weapons, people often ask, they're like, oh, what's your false positive rate? And if I give it to you as a number or a percentage, I don't really think that means much because there's so many different ways of measuring them. 0 point, however many zeros is what I'd throw out at you. More important than I would say is how noisy is your system? How many operational interruptions am I going to have on a daily basis where I need to look at a detection? If we're plugging the AI directly into your, let's say, cell phone, you're probably going to get one event for every 1,000 cameras that you have per day. And that might be a true positive or a false positive. That's our average noise per 1,000 cameras. Now, when we plug in to human verification through Omnilert monitoring, that reduces that by 90 some percent, a high 90s, which means that goes down quite a bit. We're a low noise system, and it's why we're deployed at enterprise scale. Customers that have 2,000, 5,000, 8,000 cameras across a single campus, a statewide or a citywide deployment. When you add human verification, you're not just putting the decision-making capability in the hands of a person, you're also reducing any of those spurious detections to make sure that your system doesn't have a false alert based on your AI kicking out a detection that may be an edge case.
Yep, great point.
Chad, did you want to add that?
Yeah. Well, in the cases where there is a new object that we're not familiar with and we are triggering on it, that's where the retraining comes into play. So we take those alert snippets, we retrain off of that, and then all of a sudden those are now very low noise. So it's a learning, living system.
Such as lightsabers, right, Chad? All right, we exactly that's next if we hear from customers. So we're all out of time here, guys. So there are some questions we did not get a chance to answer, but if you like this format, we'll continue doing more of these webinars, provide some insights. If you have any recommendations or things that you would like to hear, just email info@omnilert.com. Somebody will get a hold of that, and we'll feed that in here. But thank you, Chad. Thank you, Eric. Thank you all for participating today. Like we were talking about, it's critical to look at security from a layered approach, and starting with the edge, starting with the exterior parking lots and open spaces is that very first level from a physical security perspective. So keep that in mind, and we hope to see you soon. Thanks, everybody. Take care.